Hello, geometry. Welcome back to section 7.3. 7.3 is called similar triangles. 7.2 was similar polygons. So we're going to be more specific to triangles, and a lot of the same stuff's going to be true. For example, remember the corresponding angles were still congruent no matter how large or small. You had a different figure, same shape, different size, and our sides, corresponding sides, are still proportional. We can use that scale factor. So two important things about similar triangles. Like I just said, corresponding angles are still congruent and corresponding sides are still proportional. So this is going to feel kind of repetitious from section 7.2, except we're going to be more specific. If you think back to congruent triangles, we were able to do things like side, 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 and angle, angle, side, and things like that. Well, we've got a couple of things that we can do with triangles. We don't have to list all of the angles that are congruent. We don't have to check that all the corresponding sides are proportional. We can use this little table. So there's three kind of shortcuts to show or to know that triangles are similar. So the first one is AA similarity, which is angle-angle similarity. So if two angles of one triangle are congruent to two angles of the other triangle, you have you have similar triangles. So notice how angles P and T both have the single arc, they're congruent. Q and S both have the double arc. Does it make sense that the third angles have to be congruent? If we put numbers in there mathematically, it would make sense, right? If this was a 40 and this was a 60, actually, you know what? If that was a 40 and this one was a 60, could you still figure out what angle R is? Well, you could, because you know that if S is 60, Q is 60, those guys add up to 100, so this has to be 80. This is also 40 because P and T are congruent, so this has to be 80. So we only have to show that two pairs of angles are congruent to their corresponding angles. So therefore, we could say that triangle, I'm going to name the first one as RQP, is similar. If I name the first one RQP, how are you going to name the second one? UST. Remember, the similarity statement, the order matters, so be really careful. I'm going to try to trick you and ask you questions. The next one is side, side, side similarity. Not like how it was with congruent. Congruent, all the pairs of sides were congruent, right? Side, side, side is similarity. So we have to have all three pairs of corresponding sides are proportional. Notice on this diagram, same triangles, only information about sides, not information about angles like the top example. But notice side PQ is A and side ST is AX. That's that scale factor thing, right? It could be 2 times bigger or 3 times bigger, but all of them have to be 2 or 3 times bigger. So in order to do that, I'd need to do some checking. I'd need to check to make sure that A over AX was the same as B over BX was the same as C over CX. Now, we don't typically solve or check a proportion, right, with 3 parts. So we'd pick 2 of them and check, cross multiply, or simplify to see if they're the same. It has to be all 3 pairs, though. Really be careful. Last but not least, side angle side similarity. 2 pairs of sides are proportional and the included angle is congruent. Remember that included angle is where the 2 sides come together. So notice how Q and S are congruent. Has to be the included angle. It couldn't be angle P and T, or it couldn't be angles R and U. And then I've got those corresponding sides are proportional, so A over AX is equal to C over CX, and angle Q is congruent to angle S. So we're still dealing with proportional sides and congruent angles. All right. And there's one more little thing down here that I want to make sure that I mention. Even though maybe we won't use these things in proofs and things, similarity is reflexive, so anything is similar to itself. Any similarity is symmetric. So if the smaller triangle is similar to the larger, then the larger still has to be similar to the smaller. And transitive properties eliminate the middleman. So if there's three triangles, the small is similar to the middle is similar to the largest, then the small and the largest have to be similar as well. Just had to put that in there for geometry's sake. So let's do a couple of problems. Let's determine whether each pair of triangles is similar. There's going to be two types of problems we do in this section, much like the last. Determine, so tell me if they're similar, tell me why, give me a similarity statement, and then the other would be using what we know to set up algebra problems. So in problem number 1, are these triangles similar? Well, I feel like we can use what we know about the triangle sum theorem, right? In this triangle LJK, if I know a 57 and a 48, does that third angle, add those two up, subtract from 180, I believe that's a 75. Over here, I've got a 75 and a 57. I don't actually even have to do any more work if I don't want to, because I know that 57 is congruent to 57. That teeny bit of work I did makes a 75 congruent to a 75. So I can actually say, yes, these are similar because of angle-angle similarity. I'm guessing you already know that angle Q is going to be 48 degrees. We can know that. We don't have to know that. Or you could have done Q instead of K. Either one would work. Second one, ooh, this one's a really good problem. So what we need to do, we have right angles, but we don't have any other angles to compare, right? So our best bet, looking back, is to see if we have side angle side similarity, because the included angles are the right angles. So we're going to set up a proportion and see if the proportion works. So we've got our included angles. Right angles are definitely congruent. We're going to set up a proportion then to see if they're similar. So on this left-hand triangle, 20 is the smaller side. So on the right-hand triangle, I'm going to use the 18, the smaller side. And then that would leave me with a 36 over 24. So smaller over larger, or smallers and largers, right? So let's cross multiply this. Let's see if it works. It's kind of a question mark. So 20 times 24, I'm pretty sure that's 480. Is that equal to 18 times 36? What is that? 600 and something, isn't it? 648? So are these corresponding sides proportional? They're not. So are these triangles similar? Not similar. I'm going to say sides are not proportional. So if the proportion doesn't work, it is not a similar pair of triangles. Sides are not proportional. All right, so we get the idea on those ones, right? These guys, number 3, we did an example like this in section 7-2. I definitely know that this angle is congruent to itself. Hopefully, do you see the little triangle sitting on top of the larger triangle? So that angle that's right on top of itself. And then I notice I've got some parallel lines. We love those arrows to tell us things. So I would say something like, these are corresponding angles. Therefore, I now have two pairs of angles, so angle-angle similarity. Number 4 looks like it's getting ready to be side angle side. So I know my angles are congruent. I would have to test out, is 8 over 4 equal to 18 over 9? So corresponding sides. I'm going to guess that's a yes. This one then, we get to do some algebra. This is everybody's favorite part, right? I think we should probably talk about maybe both of them, at least get ourselves started. And I want to talk about 5, just what's congruent, because do you see the arrows for parallel lines? So identify the similar triangles. So write a similarity statement, find x and the measures of LM and QP. So first things first, if I need to line everything up, I like to use angles. We've got a good old-fashioned at angle N. I've got myself vertical angles here, so we know they're congruent. So then I'm going to go up here to angle L. I'm going to double arc that, and then my question is, what gets double arced? Is it Q or is it P? Well, technically, these two lines are parallel, and if this is my transversal, L and P would be alternate interior angles. What do you know about alternate interior angles? They're congruent, right? So therefore, angle P has to match up with L, and then angle Q and M. So when I try to figure out what X is, I'm going to set myself up a proportion. And probably the 18 over 12, everybody's going to notice that, right? 18 over 12. 18 over 12 goes from the double to the single, double to the single for the 12. So watch and make sure. So if I do 18 over 12 on one side of that proportion, what goes on the other? An x plus 3 over that x minus 1, right? So this triangle is on the numerator, this triangle's in the denominator. So don't forget when you do these, make sure you distribute. So I'd have a 12x plus 36 equals an 18x minus 18. Do you hit pause while I do this and do it so you can follow along and do the problem? I'm going to subtract 12x and I'm going to add 18 to both sides. That and that will cancel out, so I'll be left with like a 54, I think it is, equals 6x. So x has to be equal to 9. So when I go back, don't forget, am I done with this problem? It says find x and the measures of the indicated sides. So if I asked you for LM, if I know that x is equal to 9, what would be the length of side LM over here? Probably a 12, right? Plug that 9 in for the x. What would be the length of side QP? Probably an 8. I want to make sure we talk about number 6, and then I think we can be okay. So number 6, I've got parallel lines again. Watch, this old stuff just keeps popping up. So I can do you see two triangles? Your best option might be to draw them separately, because then you can see things. So if I take this little guy out of here, that's the easy one, right? So I'm going to take that out of there. I'm going to call that K, L, M. I know this is 6x plus 2. I know, I sort of know KL. Do you know the length of KL? MK is where that parallel line is, parallel arrow. Well, the whole side, JL, is 24. So what does KL have to be? Anybody doing a quick subtraction here? I think that's going to be a 16, right? So then if I take out, let me do it in a different color. If I take out this larger triangle, so what is this? This is N, L, and J. I know this side's 24 for the whole thing. What is this whole length? If you don't want to take that out, if you want to just have it separately, this has to be both of those pieces. We subtracted in order to get this 16, but we got to put these two together to get all of side NL. So it's going to be x plus 5 plus 6x plus 2. So shouldn't that be 7x plus 7? So then, I know that L is congruent to L. So then I can set myself up a proportion. So be careful. If you don't want to write them twice like that, be careful. Make sure you ask yourself, what's the whole length? Don't just go with bits and pieces, because they're sneakily telling you information. So then we can set ourselves up a proportion. Probably one ratio, you're going to use a 16 and a 24. And the other ratio, I'm guessing you're going to have a 6x plus 2 with a 7x plus 7. And then we can go ahead and solve that. Do you need to solve it or are you good? You know how to solve these guys, right? Let me know when you get that answer, but otherwise the big part is setting up and making sure that you're looking at the whole sides. You see two triangles, and then don't forget to distribute when you do cross multiply that out. So finish that problem up, and that is it for section 7.3. Thanks for hanging out, and I'll see you next time.